Hi students, good morning. Welcome to this video session. I remain Samuel Chukwuemeka, aka Sam Dumb for Peace. In this video session, we shall discuss your Module 8 homework study guide. So let's get on my site. You click on my picture, click on mathematics, click on finite math, click on notes, module 8 homework study guide. Please, prior to viewing this video, it is highly recommended that you master the prerequisite topics. There are several videos on mathematics of finance. Then you also need to know your Module 7 homework study guide. It is highly important. These two topics, literal equations and logarithms, those two topics are also required prerequisites for mathematics of finance. Question 1. Find the rate per period I and the number of periods N for the following annuity. You have a quarterly deposits of $1,200 are made for 7 years into an annuity that pays 7.5% compounded quarterly. When we talk about compounded quarterly, that means that M is 4. M is the number of compounding periods per year. The interest rate is 7.5%. You convert that to decimal. It gives you 0.075. And the time is 7 years. So basically what you do in this topic, in this module, as well as what you did in Module 7 homework study guide, was just using the formulas and being able to substitute the variables correctly and then doing the calculations correctly. So the formula is I equal to R over M, and when you do that you get a 0.0188, approximately 4 decimal places. Okay, 4 decimal places as needed. We talked about this in prior module videos. As needed means if your answer is in 2 decimal places, that's fine. You can leave it like that. But if your answer is like more than 4 decimal places, like 5 or 6 or 7 decimal places, then you round to 4 decimal places. That is what as needed means. Then the number of periods is MT, number of compounding periods per year, times the time in years. And that gives you 28. Question 2. In this case, we have monthly payments made for 4 years at 9.1% compounded monthly. So you basically do the same thing as well. Okay. Question 3 is annual payments made for 11 years at 5.8% compounded annually. Annually means that M is 1. You follow the same formulas to get the answer. Question 4 is quarterly payments compounded quarterly, similar to question 1. You follow the same formula. So kind of do this on your own, you know, and let's bring out our calculator. This is Windows 8. Do this on your own to make sure that you're getting what I'm getting. Okay? That you are getting what I'm getting. Yeah, 0.084, which means to convert 8.4% to decimal, and then you divide by M, quarterly. So 0.021. Question 5, semi-annually. Okay. You use the same formula. Semi-annually means M is 2. Question 6, find the present value for N equal to 19, I equal to 0.054, and the payment to be $268. So round to 2 decimal places. You can find this formula in annuities calculations. A present value formula. Now this is the formula. You have some other formulas. In this case, you're using the formula that has I and N. That is, and the I and the N. That is the formula you should be looking at. So there are several formulas for mathematics of finance. Several of them. So the skill that you are being tested, one of the skills that you are being tested in this model is to know which formula to use when. Okay, when you encounter a problem as this, which formula do you use? When you encounter a different problem, when you encounter a different question, but they are still asking for the present value, but they gave MT. You know that N is M times T. If they give that, which formula would you use? So if they give a arrow M and T, you use another formula, but it's still a present value formula. Do you understand what I'm saying? You know that I is equal to arrow divided by M, and the N is equal to M times T. So what if they give you a question whereby they give you they didn't give you N, they just said they gave you M and T, and then for I they didn't give you I, they gave you arrow and M, because we saw here that I is arrow divided by M. So you use another formula that has that. Okay, so we are using this particular formula because it has I and N. So what you are being tested on is finding what formula to use when. Okay. So let me show you how you can do this with your calculator on the computer. Because I am using the computer, my desktop. I want to show you how you can do it to get your answer. But if you follow these steps I did here, I did it step by step so that I don't skip anything. You will still get your answer right. But, watching this video should be an added advantage so that you actually see it as I do it. So you have to follow order of operations. Order of operations. B PEMDAS. Bracket, parentheses, exponents, multiplication and division left to right, addition and subtraction left to right. Here, first of all, in this, we have a bracket here, and inside the bracket, we have a parenthesis, 1 plus I, and then we have an exponent, negative N, okay? Then we have subtraction, we have division inside the bracket. Then outside the bracket, we have multiplication. So let's start with the parentheses inside the bracket. Okay, 1 plus 0.054 equal to. Now, what you have to do is each one you do equal to. Each one you do equal to. If you are using this calculator, okay, I have seen students, not once, not twice, not thrice. Okay, I've seen students, they are using this kind of calculator and they are just trying to do this right away, like not doing it step by step. if you're using this kind of calculator, or if you're using TI-30X, and you're just putting this just like you see it here, trust me, you're gonna get it wrong. You will. Okay. So what am I going to advise you? I will advise you that depending on the calculator you're using, you have to, in fact, I will advise you to always do it step by step. Order of operations. That is my advice. But if you have something like a TI 84 Plus, TI Inspire, okay? And I'm not advertising for TI. They didn't pay me, okay? They didn't pay me. But I use TI as well. Now, if you have those, you could put in this exactly as it is, but you have to do it properly. Because if you don't put it in properly, then you will get your answer wrong. So it requires a little, it requires a little skill to be able to put this properly on the TI Inspire or TI 84 Plus. You put this right here, just like you saw it here, and it will give you this right away. I know some of you like it because you don't want to go through the steps of order of operations. But you now see the importance of order of operations. So what is my advice? Don't do it holistically. Don't put it in like this immediately. Just use order of operations and do it step by step. So we are going to focus on the bracket, and inside the bracket we have parentheses, which you do first. Okay, because parentheses comes first after bracket. Okay, in this case you have bracket comes first, but inside the bracket you also have parentheses, so you deal with those inside first. And inside the parentheses you have the addition, so that's what you do first. 1 plus 0.054 is 1.054. You see, that's the step, the next step. Then after that you now have exponent. You have exponent here, and you have a subtraction, then you have division, but you got to do the exponent first. Okay, so you raise to power x, you press x raised to power y, you press it. Negative 19. Okay, if you're using the calculator on your computer, the negative 19, you don't press minus now. I know that minus and negative means the same thing. But if you're using this kind of calculator, and some calculators too that you might be using, you see, if you want to get the negative, you press plus minus, this sign. In some calculators, you see it as you see the minus inside the parentheses. Okay, you see, if you don't see plus minus, you see parentheses, and then you see minus inside the parentheses. That is how you get negative 19. Okay, so I will press 19, and I'm gonna press plus minus to get my negative. You don't press 19. You don't press plus minus and then you press 19. If for this calculator on the computer, you don't do that. Okay, and I'm gonna show you this once more. So you raise this to exponent negative 19, and you press equal to. Anything you do, you press equal to. Each step you do, you press equal to. Okay, then that is how you get here. That is the next step. You see the step I did here. Now, I didn't use, when I was doing this video, I used my Casio. I have a Casio that I've been using for years. So the Casio I used, if you view the videos on mathematics of finance, simple interest, compound interest, continuous compound interest, you will see the Casio I'm talking about. I used it in that video. So my Casio doesn't have this number of digits. These are too many. Okay. So you don't want to approximate until the final answer. If you're going to approximate, then just approximate to a reasonable number of decimal places. Let's say 5, 6, 7, 8, 9 decimal places. In fact, approximate to like 10 decimal places if you want to approximate. Okay, this is 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 decimal places here. So that by the time you get your answer is 2 decimal places, because it's dollars and cents to the nearest cent, which is 2 decimal places. So by that time, you will still get a good, you will still get the same answer. But if you come here and you approximate 0.37, you will get it wrong. If you use 1 minus 0.37, you will get it wrong. So approximate at least, you know, just make it 9 decimal places. 9-digit calculator. 10-digit calculator. So make it 9 decimal places, just like this. Okay. So you now do 1 minus this. Now, if you don't want to write out, because you know I don't want to do -1, and then I know that it's gonna be negative, and then I come and just remove the negative. No. And if I don't want to write this on paper, what I do is I put this on memory. I press M+ to put this on memory. And then I just put 1 minus recall memory. Recall the memory that you just put. And you press equal to. So it gives you this. Excuse me. It gives you this 0.631846958. And then you now do divided by 0.054 equal to, gives you this. And then you now do times 268 equal to, and that's your answer. It's not, it is not difficult. Trust me. You just have to do it step by step. So let me rewind. Okay, let me rewind. I'm going to cancel memory or change memory. Clear memory. I'm going to clear memory, MC, to remove the memory. So let me just start all over again. Assuming I close this. You go to your Windows, type in calculator. You want to use this. You don't want to use this, no. You want to use this one. You click on it. And initially, when you click on it, it looks like this. It's the standard. Looks like this. Just click View and click Scientific. Okay? Then you do 1 plus 0.054 equal to. Each one you do equal to. Then x exponent y, do that, -19. Don't do minus here, 19. You will get it wrong. No. And don't do plus minus first, then 19. You will get it wrong. You press 19, and then you press the plus minus. If you are using the calculator that has that minus, then you press it. But it depends on your calculator, because some calculators will require you to press this first before you press 19. So it depends on how your calculator works. I'm just using the calculator on the computer as a reference. So equal to. Okay. Then if I don't want to write this down, I save it in memory. I press M+ to put it in the memory of the calculator. And then I now do 1 minus, recall the memory, okay, equal to. So you see, I'm doing this step by step so that I don't miss anything. And then I now divide by 0.054 equal to, and then I now multiply by 268 because I'm done with the bracket. Then I multiply, I now do multiplication. 268 equal to, and that is $3,135.83. Okay. If I want to start a new one, I just clear the memory, just like you can clear this. Okay. Question 7. In this case, you're asked to find the payment. They gave you the N. N is 114. I is 0.024. And present value is $27,016. Round to 2 decimal places. This is literal equations. So please view my videos on literal equations to see how I solved for the payment. Okay, you divide both sides by this so that you can get the payment. Okay, and let's use the calculator to do this. I have the numerator and the denominator. Let me deal with the denominator first. Okay, before I now do the numerator. Why am I doing that? Because the numerator is just a number. The denominator is where the computations are, where most of the computations are. So I will do 1 plus 0.024 equal to, then x raised to power y, I raised it, negative 114, 114, plus minus, negative 114 equal to, so that gave you this. See that? And let me save this in memory. Okay, then I do 1 minus recall memory equal to, that gives you this. See that? That gives you this. Then divided by 0.024 equal to, right? I divided this. That gives you 38 point this. Okay, I know you didn't see it here. That's fine. I did this as fraction, but we will still get the same answer. That's fine. So I want to save this as a new memory. I want to save this as a new memory so that I can now do the numerator divided by and then I record the memory. So I want to save this particular thing as a new memory. The way I did this as fraction, division of fractions. Of course, when you divide fractions and you convert it to multiplication, then you flip the fraction on the right hand side. So, but I'm just going, I'm doing this. I just did this division right away. That's fine. I want to save this as a new memory. So first of all, I will clear the memory, and then to save this as a new memory, I press M+ again. So this is now a new memory. Then I now do 27016 divided by recall memory, the new memory, and that will give me this $694.91. Question 8. In this question, you are asked to find n. So you are going to isolate n. Please, it is very important that you view the videos I did on literal equations so that this will make sense to you. Okay? N is an exponent. And if n is an exponent, to isolate it, one of the things you can do is to introduce logarithms. So please view that video and then follow these steps. I put in the steps because in this one, you will have to introduce logarithms in order to isolate n. So I did the steps here. So please view the videos I did on literal equations As at the time of this recording, there are 2 videos in the playlist on literal equations, which you can find on my website. But you find it under algebra, literal equations. Yeah, you find it under algebra. That's where you find it. And also, I put the literal equations. So there are 2 videos right here. I mean, as at the time of this recording, I might put another one. Or you just click on the link on the prerequisites. It will take you there. So please, you view those 2 videos, and this should make sense to you. If it doesn't make sense to you right now, okay, the extra thing you will do here is to introduce logarithms to both sides, and also view the videos on logarithms. It is very important. So you apply the law of logarithms. You need this in order to isolate n. Okay. Now, if you view those videos and look at this again and you still don't understand it, just let me know, please. Okay, just let me know. All right. So once we did that, let us now use the calculator to get this. So let me clear the memory. Okay, and if you want, you can clear this. You can clear it. It does not matter. Here, let me deal with the denominator first. Let me deal with the denominator first, and then I will save it as memory, and then I do the numerator. So if you follow the way I did it here, I did this as a fraction, but that's fine. If you don't like fractions, you can do all this with the calculator without doing it as fractions. So the denominator, this is 1 plus 0.01 equal to, okay, and then log of it, press log of this. So this is what we have here, 0.00432 and so on. That's what we have in the denominator. You can put this as memory, save it in memory. You can save it in memory. Now let's do the numerator. I have to do this first here. 0.01 times 13,000 equal to, each one you do equal to, then divided by 500 equal to 0.26. Okay, so this is easy for me to write down. I can do 1 minus 0.26 equal to 0.74, and then I do the logarithm of this, gives me this, right? Negative this. Negative this. Now remember, there's a negative here. There's a negative here in front of this bracket. So that negative times negative, okay, will give me positive. So that's fine. I will still multiply everything by -1. So this is what the numerator gives me. This is this right here. Okay, that's this right here, the numerator. Then you now do divided by recall the memory equal to, okay, and then you multiply by -1 times -1, and you press this -1. So it gives you this, approximately 31. Some of you will ask me, this is 30.26081215. Why did you do it to 31? Okay. This is, in this case, it's just like saying, in this particular case, whereby you have to round to the nearest integer, once it is more than 30, even if it's by 0.1, assuming you have 30.01, you have to use 31. Let me give you an example. If you if you are asked to paint a classroom and you find out, you took measurement of the area of the classroom, and then you find out how many gallons of paint you need for that classroom. And, when you're finding out, you came up with maybe 3.1 gallons of paint that you need to paint the classroom. But they only sell gallons as integers, positive integers. 3 gallons, 4 gallons, 5 gallons. Assuming, I'm just giving an example. So if you're writing the quotation, you wouldn't write 3.1 gallons because they don't sell gallons in decimal, they only sell it in whole numbers. So you have to buy 4 gallons of paint, because if you buy 3 gallons of paint, there might still be a section of the classroom that is not painted, and then you did a bad job. So it's good to now round to the nearest, to the next integer. The case happens also with this, the number of compounding periods. In this case, if they ask the nearest integer in this case, even if it's by 0.01, you have to round it to 30 to the next integer. Okay. Question 9 is future value, and this is the formula you use. You still get it under this. Okay. This future value formula, let us use the calculator to do it. So you have let me clear the memory. 1 plus 0.04 equal to, then you raise it to 40 equal to, then minus 1 equal to, then divided by 0.04 equal to, you see it, each step, then times 55 equal to, gives you this. Okay. Question 10, find the periodic payment with the future value formula. So you solve for payment. Okay. Again, this is literal equations. So, but my interest is showing you how to use the calculator on the computer to do it. That is my main focus. So please view those videos on literal equations and look at these. If you still don't understand how I isolated the variables, then just let me know, please. So let's do this one. We do the denominator here. We start with the denominator. 1 plus 0.08 equal to, then raised to power 25 equal to, minus 1 equal to, divided by 0.08 equal to. So let's save this as memory. Press M+ to save it as memory. And then 4320 divided by recall memory equal to. So you have $59.09. The way I did it like fractions. Maybe I like fractions. So you have $59.09. Okay. Here, you also have to solve for n here. And because n is an exponent, you will still have to apply logarithms to isolate n. So please, you see the importance of literal equations. So when you do this, okay, you have this formula here for n. All right, let's get it. Let's get the value from the calculator. Let me do this last one first, the denominator. Let me do the denominator first. So 1 plus 0.03 equal to, then logarithm, log of it. So in the log of it, don't press equal to again. No. If you press log, it tells you log of this. You don't need to come and press equal to again. No. So save this in memory. Then let me do the numerator. 0.03 times 10,000 equal to, divided by 200 equal to, plus 1 equal to 2.5. Okay, log 2.5. Then I just do log of that. Okay, gives me this. See? Then I just do divided by, recall memory, what I had in the denominator, equal to. So that also gives me 31 approximately. Okay. Question 12. Samdom Capital offered an annuity that pays 5.1% compounded monthly. If $2,329 is deposited into this annuity every month, how much is in the account after 12 years? How much of this is interest? Okay. Now, this is still, like I mentioned this earlier in this video. You have several formulas, but which one do you have to use? Okay, in this case, they gave us now the interest rate R, and they gave us the compounding periods per year, number of compounding periods per year M, and also the time 12 years. So you don't need I and N. They didn't give us I and N. Okay, like in the previous one we did, whereby we have I and N. This is still future value formula. It is still that. But in this case, you have I and N. But in this case, you have M, R, and T. So you use that. It's the same future value, but the thing here is knowing what to use when. Okay. So let's go ahead and do this on the calculator. I clear the memory. Because my denominator is just one value, so I leave it. I do the numerator because that requires more computations. So I have a 0.048 divided by 12 equal to, okay, then plus 1 equal to, because this is all in parentheses, I have to finish the parentheses first. Then I raise it to 108. Exponent 108. Please don't do exponent 12 times 9. You will get it wrong. Because if you do that, it will be like exponent 12, then times 9. You've got to do the multiplication of the exponent. Okay, which gives you 108. Okay, please. If you do if you do that 1.004 exponent 12 times 9, then you're gonna get it wrong, because it will do it as 1.004 exponent 12, then whatever you get, then times 9. That is the way it will look at it. So you just have to do 1.004 exponent 108. You have to do 12 times 9 and write it down somewhere. Okay, so you just raise this to 108 equal to, then you do you see that's this one right here. See, I'm putting all this in steps so you see the way it works. Then you do -1 equal to, okay, then you do divided by 0.048 equal to, then you do times 29244 equal to, okay. So they asked you to approximate to the nearest dollar. So that would be $328. I mean, $328,391. Okay? So that's what you got here. Do you understand? Now, to find the amount of interest earned, you use this formula. Okay? You use this formula. In this case, you do the parentheses first here. 2437 times 108 equal to, then save this in memory, and then you now use, please don't use approximate. You only approximate at the final answer. So just use what you had initially, 328 390.8529 minus recall memory equal to, and you have this, you now approximate here, $65,195. Okay. Question 13. The Peters deposit $395 per month into an account that pays 6% compounded monthly. How much will be in the account in 3 years? Round to the nearest dollar. So you still use the future value formula. And let's do that with the calculator. Clear memory. So my denominator is just a number, so I just leave it. I do the numerator. 0.06 divided by 12 equal to, plus 1 equal to, then raised to power, not 12 times 3, raised to power 36 now, equal to, -1 equal to, then divided by 0.06 equal to, order of operations. You want to finish the bracket first. Then times 395 equal to, then times 12. Although you can do times 395 times 12, right away. And you now have this $15,538. Okay. Question 14. Chukwu Emeka Annuities offered an annuity that pays 6.0% compounded monthly. What equal monthly deposit should be made into this annuity in order to have $153,000 in 15 years? So in this case, it's future value formula, but you have to solve for the payment. Okay, and I explained the process here, so please view literal equations so you can have the idea. All right, so this is the formula here. Let us do this in the calculator. My numerator is just a number, so I leave it. I concentrate more on the denominator. I have a bracket, and I have a bunch of stuff in that bracket. Now, 12 times 15, let's do it first. 12 times 15 is 180. So, write 180 down in your paper. Okay, write 180 down in your paper. That is the exponent. Okay, so now let's go back, on order of operations. 0.06 divided by 12 equal to plus 1 equal to exponent, okay, raised to power, raised to exponent, 180. Please don't do raised to power 12 times 15. Please don't do that. Okay, raised to power 180 equal to, then I'm done with this, then minus 1 equal to, then divided by, so I now do this denominator in the bracket, divided by 0.06 equal to, then times 12 equal to. So this is what I have in the denominator. I put it in memory, okay? I now do 153,000 divided by recall memory. Recall memory equal to this. So that is round to the nearest cent. That would be $526.10. Do you understand? Okay. Question 15. CompuWorld, a technology firm, estimates that it will need 70,000 in 13 years to replace their supercomputer. If it establishes a sinking fund by making fixed monthly payments into an account paying 3.3% compounded monthly, how much should each payment be? Round to the nearest cent. So we're going to use the sinking funds formula under annuities calculations. You take down the formula. And this is the sinking funds formula here. So let's do it with calculator. Clear the memory. I will do this bracket first, and then I will now do this. I multiply by 70,000, then divide by 12. But I will do this bracket first. The numerator inside the bracket is a number, so I leave it. I focus more on the denominator. So let me do 12 times 13 first and write it down. 12 times 13 equal to 156. I write it down on my paper. Then I now do 0. Inside the parentheses, you have division, you have addition. Division comes first. So 0.033 divided by 12 equal to, then plus 1 equal to exponent 156 equal to, okay, see that, then minus 1 equal to. So let me save this as memory. Let me save this in the memory. And then I now do 0.033 times, oops. So let me clear this, just clear it, that's fine. 0.033 divided by recall memory, okay? Recall memory equal to, gives me this. Now times 70,000 equal to, then divided by 12 equal to, see that? $359.94. So please practice on this. Practice on this, please. Practice on it. And it's not difficult. Practice on it. And if you don't get it, I am here to help. Okay? And these are references. So thank you so much for coming to this video session. And if you have any questions, please feel free to ask. And you have a great day.